Antarctica, the largest mass of ice on the planet by far. A friend of mine said in 1978, if you see the breakup of ice shelves along the Antarctic Peninsula, watch out, because that should be seen as an alarm bell for global warming. And actually, if you look at the peninsula up close, every place where you see one of these green blotches here is an ice shelf larger than the state of Rhode Island that has broken up just in the last 15 to 20 years. I want to focus on just one of them. It's called Larsen B. I want you to look at these black pools here. It makes it seem almost as if we're looking through the ice to the ocean beneath, but that's an illusion. This is melting water that forms in pools. And if you were flying over it in a helicopter, you'd see it's 700 feet tall. They are so majestic, so massive. In the distance are the mountains, and just before the mountains is the shelf of the continent there. This is floating ice, and there's land-based ice on the downslope of those mountains. From here to the mountains is about 20 to 25 miles. Now, they thought this would be stable for at least 100 years, even with global warming. The scientists who study these ice shelves were absolutely astonished when they were looking at these images, starting on January 31, 2002, in a period of 35 days, this ice shelf completely disappeared. They could not figure out how in the world this happened so rapidly. And they went back to try to figure out where they'd gone wrong, and that's when they focused on those pools of melting water. But even before they could figure out what had happened there, something else started going wrong. When the floating sea-based ice cracked up, it no longer held back the ice on the land, and the land-based ice then started falling into the ocean. It was like letting the cork out of a bottle. And there's a difference between floating ice and land-based ice that's like the difference between an ice cube floating in a glass of water, which when it melts doesn't raise the level of water in the glass, and a cube that's sitting atop a stack of ice cubes, which melts and flows over the edge. That's why the citizens of these Pacific nations have all had to evacuate to New Zealand. But I want to focus on West Antarctica, because it illustrates two factors about land-based ice and sea-based ice. It's a little of both. It's propped up on tops of islands, but the ocean comes up underneath it. So as the ocean gets warmer, it has an impact on it. If this were to go, sea level worldwide would go up 20 feet. They've measured disturbing changes on the underside of this ice sheet. It's considered relatively more stable, however, than another big body of ice that's roughly the same size. Greenland would also raise sea level almost 20 feet if it went. A friend of mine just brought back some pictures of what's going on in Greenland right now. Dramatic changes. These are the same kinds of pools that formed here on this ice shelf in Antarctica. And the scientists thought that when that water seeped back into the ice, it would just refreeze. But they found out that actually what happens is that it just keeps on going. It tunnels to the bottom and makes the ice like Swiss cheese, sort of like termites. This shows what happens to the crevasses, and when lakes form, they create what are called moulins. The water goes down to the bottom and it lubricates where the ice meets the bedrock. See these people here for scale? This is not on the edge of Greenland. This is in the middle of the ice mass. This is a massive, rushing torrent of fresh meltwater tunneling straight down through the Greenland ice to the bedrock below. Now, to some extent, there has always been seasonal melting, and moulins have formed in the past, but not like now. In 1992, they measured this amount of melting in Greenland. 10 years later, this is what happened. And here's the melting from 2005.